I will be talking about how HT Condor helps us at the Rubin Observatory's United States data facility, which is at SLAC. And after that, I'll also describe some other projects at NCSA where we benefit from HT Condor. So Rubin Observatory, it's been under construction for some time now, and it's getting close to its showtime. So it's had important milestones recently and more coming up in 2024 with the first photon, first light, and operations to begin soon after that in 25. So at that time, the 10-year survey, LST survey will begin. And so the project's getting ready for 20 terabytes of data each night. And so this data will be managed at 3 key data facilities. So there's a US data facility, and then also a French and UK DF. And so data is initially transferred from Chile to SLAC. And then after that, it gets replicated with Ruscio and over to, select subsets go to France and the UK. And the project has a lot of different kinds of processing to do. So I'll just mention, highlight, a couple. So there's first going to be sort of a systematic production that's going to go across all these sites. And that's going to be managed with Panda. And so that's sort of more, predictable, systematic. But we also, to sort of support that production, there's going to be work of developers and scientists at the USDF. And this is going to be a bit more varied. It's going to be multiple users. And it's still going to be large scale. That scientists and developers have to run against large data sets to verify things. So this is targeted for use using HT Condor. And this will run over a Slurm cluster. And so for the workflow component, the project has a sort of generic piece called the BPS, batch production service. And then that generic piece sort of becomes concrete with plugins for different systems. So there's a plugin for Panda and Parcel and also HT Condor. And the HT Condor plugin is how we make use of DAGman workflows. So the USDF has a sort of a shared facility. So the S3DF is a Slurm cluster facility used by multiple projects, including Rubin. And there's a good number of nodes and cores to use, and this number seems to keep increasing. So there's definitely resources available. But from the perspective of running our control BPS HT Condor, we have no persistent Condor pool. So the Condor pool has to be supplied by some sort of glide-in mechanism. So we have a means of supporting that with some Python packages within our software stack. And so the way that sort of works is we'll run a central manager and access point on our development nodes. And so those start up, and then there's no worker nodes, and those have to be supplied then by the users running gliders. And it's a pretty simple mechanism. So our package supplies a allocate nodes facility utility, and there's command line arguments for users to specify. They can describe, their glidance. So they sort of get to choose. They can pick the number of glidance they want to run and how many cores, like what chunk size of a node to take. And then the general sort of glide-in allocate nodes utility works against a platform package that supplies the templates, and that information gets parsed into the template. And we've had this software kind of around for a long time. And so we've used it back on old HPC machines.
We used it on the blue water system to run large-scale exercises there. But we've recently updated it now to also run at the USDF. And so where are we right now? Our current status is that, well, we're off to a start. Users can, it's working. Users can run their jobs across thousands of cores. But we're trying to make things better because we do have some limitations. And that sort of comes in the area that this facility doesn't have any means to sort of maintain the glide-ins through a workflow. So if a workflow kind of waxes and wanes in size, then glide-ins can time out, and then a user has to sort of resubmit by hand or set up a tricky cron job. So we're thinking about how we can support these end-to-end workflows, better. And so the talk yesterday, Dagman talk yesterday, describing the service nodes and provision nodes. So we're thinking about whether we might be able to take that sort of functionality and integrate that sort of into the BPS and Dagman management. So maybe that can, take care of that for the users. So we're thinking about that. And we're also thinking whether we also might, maybe change strategy sort of altogether and maybe see if we can benefit from these open science grid containers, the factory front end. So we could, change strategy and try this approach if we sort of can learn how to learn more about these tools. And although we do have some constraints though, and that our users are kind of used to having ownership of their output files. And if we set up a factory that runs on a service account, that might break that. And a factory might also sort of supply, glide-ins of one size fits all, and our users might be used to, customizing. So we're that's sort of a decision point we're at now about whether we keep building on what we have or whether we try to benefit from existing services. And just overall, the general success of HT Condor at USDF also has the project thinking that we might just set up a small pool down at the summit in Chile. And so that's sort of an idea. So that's sort of the status with Rubin. And in addition to that, I wanted to mention how we use HT Condor actually in a lot of projects that NCSA is involved in. So Rubin is example number one, but we've also been using Condor in the dark energy survey for many years, and that project is now in the late stages, but we're still running some productions over the survey footprint. And recently we've done work at Fermilab using their new job sub utility, and that's working good for us. And the glide-ins, the running glide-ins with that is actually very reminiscent of the Rubin case, where we have operations people running the Dagman workflows, and then I get to serve as the glide-in factory. And I'm also doing some work setting up a Frontier Squid to see if that can support some of the South Pole telescope factories. And another large project that we're starting to get involvement in is the CMBS4 project. And we've been doing some prototyping for that project in the fabric test bed. And I wanted to spend a little time talking about those two things. So CMBS4 is an early stage project, and it's targeted to run like in the 2030s. So this is a ways out. It would be a millimeter wave survey that would run at two sites, one in the South Pole and Chile. And some of the science goals of CMBS4 are related to transient phenomena, and NCSA's involvement is in this area. And so we are
we're looking to prototype the sort of detect transients and announce to the community via a sort of a prompt processing type scenario. And so to do that, that's where we started looking at the Fabric test bed. And so Fabric is sort of based out of Renzi, if I think that's correct. And this is sort of a kind of a cloud, kind of an intranet, but it's a programmable infrastructure where you can sort of customize and build up your infrastructure full of VMs and networks. And there's many sites that have resources, and they're all connected by these high-speed networks. And so users can work in this test bed, and they can start up VMs and make networks and route them together. And they can do this through a Python API. And so we've started working with this. And so this is kind of what Fabric, all of Fabric looks like. And so each link has a potential for 100 gigabits per second. And in our prototyping, we sort of to sort of represent our data coming from the south, coming from Chile or South Pole. So we mocked that up using the FIU site. And when you start up your resources in Fabric, we call this a slice. And so it might look something like this. So you start up your VMs at the various sites, and you can create networks at the sites and sort of connect them, your machines up with a NIC. And so this is sort of the picture of the slice at the beginning, and then you can route these together. And so after starting up your resources in Fabric, the first thing that immediately comes to your mind is, can I run HT Condor on these machines? And we see that we can. And so the way we go about this is that we create a level 3 IPv6 network at each of our sites, and we add our VM to it, and we add the routes. And then we configure Condor on all these machines, sort of using the IPv6 address that we've set up on these networks. So we set the collector host to the IP of one of these machines and point all the other machines to it. And so we think that as we start this up, that we now have a pool that's running over these networks that we've set up. And sort of the way we've sort of envisioned this then is we start up a workflow on our central machine, say in this example at NCSA, and then we submit jobs to the pool, and those can pull data from our mock observatory at FIU. And for performance transfer over these networks, we found that a tool like BBcopy works pretty well. And so we're leaning towards using that. And so, yeah, so I guess we're looking forward to the BB Condor, HT Condor plugin. And so, so this is the prototyping, the study that we've done to date, and we're going to continue to work with this to sort of try to set up, prompt type processing where we can make detections and then issue alerts. And so I can stop there.